Quick review, sections 1.2, 1.3, functions and their graphs. We'll be going through how to figure out the domain of a function without a graph. Key concepts. You're going to think of this as three categories: the good, the bad, and the ugly. So three things that you're going to look at, three types of functions. One is a polynomial. So a polynomial function, these are examples of polynomial functions. 3x minus 2. Here's a quadratic. Here's something with messy coefficients, but the exponents are all positive integers. These are all polynomials. The second category is radicals. Radicals have a square root or radical symbol. So this is an example of a radical, square root of 3x minus 2, the fourth root of x plus 4. The third category are fractions or rational expressions. So you have 3 over x, 2x minus 1 over x squared plus x, and the third one as well. These are all rational expressions or fractions. So if it's a polynomial, it's a good function. The domain is all real numbers. You can plug in any number you want into the function. If it's a bad function, think of radical, so underline the word RAD. We don't want whatever's inside of the radical to be negative, which means we want it to stay positive. So we have to restrict whatever's underneath the radical symbol to be greater than or equal to 0. Third category is the ugly. That's a fractions. If it's a fraction, then we're going to look at the denominator, and we do not want the denominator to be 0 because we cannot divide by 0. So we're going to look at what value or values make the denominator 0. Let's go through some examples. Okay, so we're going to find the domain for this function. F of x equals 5x squared plus 2x minus 1. First, identify which of the three categories. Does it fall into the good, the bad, or the ugly? Since it's a polynomial, this is a good function. If it's a good function, then your domain is all real numbers. So there's a couple ways we can write this. We can write an interval notation, all real numbers going from negative infinity to positive infinity. You can write down the words all real numbers. Or you can write something a little fancier that looks like this. In set notation, x is in a set of, and then you write a fancy r. Okay, let's try another one. Again, we're looking for the domain of the function. First thing is to identify what kind of function it is. So is it a good function, a bad, or ugly? Remember, good is your polynomials. Bad means it's a radical, and ugly means it's a fraction or a rational expression. So this has obviously got a radical symbol in it. It's a square root. So this is a bad. So if it's a bad function, we have to look at what's underneath, and we have to restrict it. We want it to only be positive. So you want the t minus 9 to be greater than or equal to 0. And then you solve that, add 9 to both sides, and then you just rewrite it with the domain letter D, and you can write it like this. If you want to put the brackets around it, that's fine. We're going to keep the notation pretty simple. Let's try the third one. Find the domain again. First step is to identify it. Again, we have the good kind is the polynomials. The bad is the radicals or rad, and the ugly kind of functions are its fractions. So on this one, it's a fraction, so we have this guy. So for fractions, we're going to identify the denominator, and since we cannot divide by 0, we want to figure out what value for x makes the denominator 0. So we're going to solve this, set it equal to 0, solve it. So x equals negative 9 over 7, and that's the number that we want to stay away from. That's the number that's going to make the denominator 0. X cannot equal negative 9/7. We can put in any other number except that. Okay, so let's find let's go ahead and review of finding the domain without looking at a graph.